All right, let's dive in. Today we're talking about one of the biggest, most ambitious dreams in all of technology, the grand scientific quest to build a machine that can actually think, reason, and learn like a human.
I mean, the AI on your phone is pretty amazing, right? It picks your next song, it gets you where you're going. It's definitely smart. But here's the real question. Does it think? Does it actually understand the world around it? That's the huge gap we're going to dig into today. The difference between just doing a task and truly thinking.
To really get what this whole quest is about, we've got to understand the ultimate prize. And trust me, this isn't just about making our apps a little bit smarter. No, we are talking about a fundamental shift in what intelligence even means.
So, think of it like this. On one side, you've got narrow AI. That's the stuff we use every single day. It's absolutely superhuman at specific, focused tasks, like playing a game of chess or recognizing a face. But on the other side is the real goal, human-level AI, or HLAI. And this isn't about being the best at just one thing. It's about having that broad, flexible ability to handle all sorts of different things, like we do.
Researchers call HLI the holy grail of the field, and for good reason. I mean, this is the ambition that kicked off the entire field of AI way back in the 1950s. The original dream was to build a machine with skills and inner workings so similar to ours that you literally couldn't tell its work from a human's.
So why aren't we there yet? This is a really great way to think about it. We see these incredible breakthroughs in one specific area, like with language models, and we immediately think, oh, we must be close. But it's kind of like the Wright brothers' first flight. That moment was monumental for sure, but it was a long, long way from that little hop to jumbo jets crossing the ocean. A single success just doesn't mean the whole puzzle is solved.
So how in the world are researchers trying to tackle this massive challenge? Well, you can think of them as moving along four major connected paths. Each one is a critical piece of the puzzle, and while each has seen some amazing progress, they've all run into some pretty serious walls too. So let's start with the one you've probably heard the most about, machine learning. This is basically the engine that powers almost all modern AI, and it's all about systems that can learn directly from data. And this brings us to a really fascinating paradox. On one hand, machine learning can achieve superhuman skill in these very specific controlled environments, like mastering a complex board game. But, on the other hand, even the most gigantic models have, and this is a quote, no perceivable conception of understanding and no cognitive agency whatsoever. They're incredible pattern-matching wizards, but they don't actually get what any of it means.
Which naturally leads us to our second path, natural language processing. This is the big quest to teach machines our most human of skills, language.
Now, NLP is what gives us the chatbots and voice assistants we talk to every day. But here's a quick reality check. We've been at this for decades, since the 1960s with chatbots like Eliza. And after all that time, there's not a single system today that has the dialogue skills of a small child. They can process the words, yeah, but they completely miss the deep contextual understanding that makes a conversation actually mean something.
Okay, our third path is all about giving machines a sense of sight. Computer vision is the attempt to let AI see and interpret the visual world just like we do.
And these systems have gotten unbelievably good at recognizing and tracking objects in a photo. But the real goal isn't just identifying pixels. It's about seeing things holistically, the way an animal does, understanding context and relationships. Today's systems miss that bigger picture, and they also tend to ignore really crucial things like whether a person can actually trust what the AI claims it's seeing.
And that brings us to our fourth and final path, which is all about giving AI a body. Robotics is about creating machines that can physically move, interact, and learn from the real world.
The robots we have today are amazing for very specific pre-programmed jobs, say on an assembly line, but they are a universe away from the flexible intelligence of a toddler. They can't understand complex instructions on the fly, and they can't do what's called online learning. That is, the constant trial and error process a child uses to figure out how the world works.
So when all four of your main paths are proving this challenging, what do? Well, you go looking for a new map. And researchers are finding that map by turning to the original thinking machine itself, the human brain.
This has led to this really amazing interdisciplinary approach. So step 1, study human cognition to understand our mind's software. Step 2, analyze the brain's actual physical hardware, its wiring, through neuroscience. And then step 3,
Take all those insights and try to build a totally new blueprint for an artificial mind.
So what's the big insight from cognitive science? It's that we humans don't just process data, we organize knowledge using symbols and relationships. The idea is that by building these things called integrated cognitive architectures, researchers are hoping to finally give AI that ability for symbolic reasoning, to bridge that gap between just matching patterns and actually understanding.
And from neuroscience, we're learning just how incredibly efficient our brains are. The brain stores knowledge in these super complex neural patterns, but, and this is the genius part, it's constantly pruning away the connections it doesn't need to save energy. If we could copy that principle, we could build AI that isn't just powerful, but also way more robust and less energy hungry.
Of course, this whole quest isn't just a technical problem. It brings us to the final and maybe the most important part of the puzzle. It's not just about if we can build human-level AI. It's about what it's going to mean for all of us when we actually do.
The potential impact here is just profound. We're talking about the automation of white-collar jobs, a seismic shift in the entire economy, and a desperate need for our education systems to focus on lifelong learning. But it goes so much deeper than that, right? It touches on social trust, with the risk of automated propaganda, and even our own psychology. What happens when our decision-making skills and social connections start to fade?
And this leads to what might be the single biggest challenge of all, something called value alignment. Can you really take the vast, complex, often contradictory mess of human values and just summarize it into a neat little system for a machine to follow? This is one of the most difficult, unresolved questions in the entire field.
So, after exploring all the paths, the new maps from brain science, and the huge ethical questions, what's the verdict? Well, the destination of human-level AI is still very, very far away. This quest is a marathon, not a sprint.
So what does the road ahead look like? Right now we're in this phase of isolated skills. The next big step is going to be a slow, gradual integration of all these different abilities. That final goal, true generalization, isn't going to be some single eureka moment. It's going to be a painstaking, step-by-step process of building and combining capabilities over time.
And we'll end on this one provocative thought. This journey toward human-level AI, it's not a one-way street. The systems we build will absolutely, inevitably, change how we, their creators, think. So the ultimate question isn't just about what we're building, it's about what we are becoming in the process.